So yesterday, you guys learned about probability distributions. You created them, you created graphs for them, you looked at all the characteristics of them. So now today we're going to build off that, and we're going to find the mean, variance, and standard deviation for our probability distributions. So the first example matches with the example from yesterday. Example 1 matches up. Construct a probability distribution for tossing 2 coins. You did that yesterday. And we want to find now the mean number of heads. That's what we want to do. Just as a refresher, I know you guys have your sheets, but I'm going to just recreate it up here. So number of heads. That was the event we were looking at, was the number of heads. And then we had the probability. So we could have had 0, 1, or 2 heads show up if we're tossing 2 coins. 0 was a fourth, 1 head was a half, and 2 heads was a fourth. So you created this yesterday. Now our goal today is to find, first of all, the mean for that distribution. And then we're going to move on and also find standard deviation, or excuse me, variance and standard deviation. How do we find the mean? A little step-by-step for us. We multiply each possible outcome by its corresponding probability, and then we find the sum of all those products. So for example 1, the mean, and we're going to go back to the symbol mu. Mu is our symbol for population mean, and everything is included here. We're not taking a sample. This is everything from our sample space, so it's going to be our mu. First possible outcome is a 0 times its corresponding probability. So if we had 0 heads, we look at our distribution, the probability corresponding to that was a fourth. Plus our next possible outcome was 1 heads. The probability we get 1 head is a half. Next possible outcome was a 2, and its corresponding probability was a fourth. Order of operations, we multiply first and then we add. Or that's something, again, you can put right into your calculator. There's no shortcut formula for this on the calculators. So you can enter that in, parentheses and all. If you want to put decimals for the fractions, you sure could. Just make sure you're not rounding. These fractions turn into really nice decimals. So this mean actually comes out to be just 1. So each possible outcome times its corresponding probability that we found in our distribution. That's how we find our mean. Now I do want to make sure, and I know we have the process, we just did an example, but I want to keep exposing you guys to the formulas. All the different symbols. So if we look at this just as the generic formula, not specifically for tossing 2 coins, there's our mu, our symbol for our mean. All the capital X's are just all of your different outcomes. So our outcomes for tossing 2 coins and looking at the number of heads, we had the outcomes 0, 1, and 2. The next example we'll look at was when we rolled the 2 dice and we looked at the sum. We had an outcome of 2, 3, 4, 5, 6, 7, 8, all the way up through 12. Those are all the capital X's. The little subscripts just help us distinguish between each separate outcome. Corresponding probabilities, I'm hoping that after all our work with Chapter 4 that we're getting used to that notation with the capital P and then in parentheses whatever the event is we found the probability of. So again, I just want to keep exposing you guys to all these different symbols. I want to keep exposing you to the formulas, not only just the step-by-step. Capital sigma, remember, that tells us we need to add all those together. That's our sum. We need to add all those different products together. Your rounding rules, 1 more decimal place than the outcomes, so whatever your outcomes happen to be. So for tossing the coins, looking at the number of heads, the outcomes were 0, 1, and 2. They were to the nearest whole number. So if we would have had to have rounded, we would have went to the nearest tenths. Go to one more decimal place value than your outcomes themselves. Any fractions, we want to try to keep our answers exact whenever we can. So any fractions, just write them in lowest terms. That's all we're looking for. I want to give you guys a chance to try this out. Examples 2 and 3, they match up with examples 2 and 3 from yesterday. So you already have the construct part done. You've already constructed the probability distributions. You guys did that yesterday. So now we want to look at what will the mean be for our sum of 2 dice and then for the cars rented per day. Like I said, there's no calculator shortcut for this. So our mean, if you look at your distribution from yesterday, for example, 2, your first possible sum was a 2. The probability that we got a 2 was 1/36. Next possible outcome was a 3. And then now it's up to you if you want to use the simplified fractions or not. It doesn't matter. In the distribution yesterday, we simplified. It was 2/36. We simplified it to 1/18. It doesn't really matter at this point. When you do your distribution, I want your fractions simplified. But if you're just throwing them in to find the mean, either way will get you what you need. It's totally up to you. Next sum was 4, and that was a 12th probability. 5 was a 9th. 6, 5/36. And again, these numbers should be coming from the distribution you did yesterday. So if you're doing a lot of head bobbing with me, I want to make sure you know where these numbers are coming from, that I'm not just making them up on my screen. I'm going to run out of room. Now this one's a little bit longer. It takes a lot of entering things into your calculator. The mean should come out to be 7. So I do want to give you guys a chance here to make sure you're okay with entering that in your calculator. If you're okay with number 2, I want to go ahead and let you try number 3. All I'm going to tell you for number 3 is that your mean should come out to be 5/3. Or if you want to write it as 1 2/3, or if you want to write it as 1.6 repeating, your choice. So check it out with your calculators. Try out number 3. Let me know what I can help you with right now. So if we're able to find our mean, the variance isn't much more difficult, to be very honest. The variance, remember, for our data set was always the average squared distance each value was from the mean. So when we deal with variance, we know we're going to be squaring something along the way. And in this case, you're squaring each outcome. So you're going to multiply the square of each outcome by its corresponding probability. So how you start the variance is really similar to finding the mean. The mean was each outcome times its corresponding probability. Now it's the square of each outcome times its corresponding probability. So really similar starts for the two. Again, we find the sum. So really similar to the mean. And then last but not least, we subtract the square of the mean from our sum. And I'll show you guys the formula and things, and we will do some examples, don't worry. But I know for a lot of us in that first unit, when we found variance and standard deviation and things, a lot of us defaulted to the calculator, and which was fine, but we kind of lost out on that meaning of looking at each value being the distance from the mean. To find the variance, we had to take each value minus the mean. So sometimes we forget and we think, well, why do we have to do anything with the mean to find the variance? We have to. We have to do the difference. We're looking for the distance each value is from the mean. So the mean has to be included in our computation for the variance. I know we kind of lost that defaulting to the calculator so much. So actually putting it into symbols for you. Remember that capital sigma, or actually let's start with the lowercase sigma. Lowercase sigma squared, that represents our variance. That's our population variance. Capital sigma, which is that kind of goofy looking E thing, means our sum. Means we need to add all of those products together. We haven't really seen brackets many times when we had to find the sum, but we have to signify with the brackets that we're going to square each value times its probability. We're going to add those things together and then subtract off the square of our mean. So we have to signify by these brackets, these products are the things we're adding together. Once we have that sum, once all those products are added together, then we get to subtract off the square of the mean. That's done last. That's done very last for us. Now for standard deviation, if it was me, I wouldn't rewrite the whole formula. I'd make sure I had the symbol. Now it's just our little lowercase sigma. It's no longer squared. And I would just simply write there, it's the square root of the variance. You can rewrite the whole thing if you'd like, and that's fine if you want it for your notes. But same as when we just had our data sets last unit, variance and standard deviation go hand in hand. Standard deviation is just the square root of the variance. Or variance is standard deviation squared. Either way. So let's take a look, staying with the same three examples, so tossing 2 coins, rolling 2 dice, and our car rental example. Let's find variance and standard deviation. For the first example, and that was the tossing 2 coins, we're looking specifically at the number of heads. The first possible outcome was if I toss 0 heads. So I take that first outcome, and now since I'm looking at variance, I square it. Then I multiply it by its corresponding probability. So it's really similar to finding the mean. Biggest difference is we're going to square each outcome first. Next possible outcome was 1 head. We square it. Its probability was 1/2. 2 heads. Square it, its probability was 4. The part we can't forget, and it does happen, we can't forget to subtract the square of our mean, or in other words, the mean squared. So I'm just going to make a little note here that for this example, we found this earlier. We found the mean for example 1 to be 1. So what I want to do is just put up, I'm going to put up what the answer should be for 2 and 3 and just give you guys some time to play around with those. Now again, example 2, I know it takes a little longer to do. So maybe try example 3 first, and if example 3 is okay, then maybe not take the time to do 2. I know 2 has a lot of different outcomes. Standard deviation, almost forgot, standard deviation for this one would just be the square root of the variance. Variance comes out to be 1/2. Square root of 1/2 is roughly 0.7 or 7/10, roughly. So again, for 2 and 3, I'm just going to go ahead and jot down what they should be. And again, I do not blame you if you shy away from example 2 and maybe you start with example 3. If example 3 is okay, then you'd probably be okay on 2. If you want to do both, you can. But I would start with 3. Start with 3. If 3 is okay, I wouldn't take the time to do 2. You're okay setting them up.